So, welcome back students. This particular lecture will be trying to focus you another new concept which is named as desymmetrization. Now, desymmetrization often plays a very important role in designing a synthetic strategies, and basically we will be trying to focus on a normal desymmetrization. Desymmetrization can be of two different types. We can call is achiral desymmetrization or chiral desymmetrization. As the name implies, achiral means the desymmetrization of this kind of strategy will give you a achiral molecule, and this case will be give you a chiral molecule. Now, in this case of chiral desymmetrization, there are different desymmetrization is called enantioselective desymmetrization or diastereoselective desymmetrization. But definitely things will be little bit complicated. We probably will talk about few examples of ED and DD later on, but now if you consider what is exactly a desymmetrization, then I will say that I will talk about a very specific example. I am saying that you are having this compound. Okay. Now, this is starting material, you target which I am giving you, that you please convert the starting material to this target. Now, initially do not focus about the functional group based interconversion, definitely that is your main key point, but as I said, initially try to have a visual communication with the target molecule. The only difference is the initial molecule is symmetrical, having a sigma v. This part is basically you create something which makes the molecule pseudosymmetric or the molecule has been desymmetrized. So, pseudosymmetry and desymmetrization are kind of similar thing. Basically, the symmetry of the starting material has been removed or you disturb the symmetry. Now, in principle probably I can give you a series of problems where I can just ask you that is symmetrical starting material, a symmetrical starting material was given to you, symmetrical starting material was given to you, and you need to do some FGI to desymmetrize the molecule, Now, how you do the FGI? These FGIs are basically we have already discussed couple of key transformation which is required to a symmetric molecule. The FGIs are very simple, the same FGIs which you have already learned, we will use those things, but the concept is the starting material will be giving a symmetrical starting material. You basically need to do it in a straightforward simple way, and normally when we talked about this particular desymmetrization, we will talk about either a single step desymmetrization or a multiple step desymmetrization. So, there are definitely two different ways, single step and multiple step. Now, in principle single step is always preferred because this is step economical and you are cutting down the cost, step economical. Multiple step also sometimes you have to use it based on your prior requirement. In addition, as we talked about the other things, the second part. So, this all these things come into the achiral desymmetrization. Now, I just try to give you a information what is chiral desymmetrization. Now, take a molecule something like this. This molecule is basically 2-methyl 1,3-propanediol. This molecule is having a nice mirror plane of symmetry. Okay. You can basically put a mirror in between which basically cuts the molecule into equal halves. So, sigma v fine, and the presence of the sigma v basically makes OH1 and OH2 are enantiotopic to each other. So, OH1 and OH2 are enantiotopic. Fine. Now, I am saying that is there a way you can desymmetrize the molecule? You said that definitely sir possible. You have both the OH, why don't you do a selective protection of one of the OH? The protection group chemistry all of you have already learned. So, what you do is stoichiometric, imidazole and let us say TBS chloride, you are using it 1 equivalent. Okay. So, in principle you are doing it. You say okay, I am having 2 TbOH group. So, one of this thing is protected. Now, the big question mark is these compounds have equal reactivity under this condition. Now, I say that you are only touching OH2, why not OH1? The thing is after the desymmetrization you will see that this molecule is no longer achiral. The center is now stereogenic center. Initial this is the prochiral center because CH2OH and CH2OH are same. Now, once you convert this OH one of the OH to OTBS, you basically bringing a stereogenic center. So, things become little bit complicated. Now, I am saying that you have only considered about OH2, what about the OH1? Now, I am saying that okay. So, now you convert the OH1 also, which will be giving you this OTBS where OH2 is remains similar. Now, you analyze these two compounds. These two compounds are what? These two compounds are basically mirror images. Compounds are mirror images, though the absolute configuration was not given here. So, desymmetrization which lead you enantiomers or diastereomers or a stereogenic center or particularly you can call stereoisomers, these are basically falls in the class of chiral desymmetrization. Chiral desymmetrization. Okay. Now, in this case as enantiomers will be generated, you can call this as a enantiomer selective desymmetrization. You can also have a diastereoselective desymmetrization if the final products are diastereomeric to each other. So, this is a very simple and straightforward way, but I am saying simple, but in reality it is very difficult. So, probably we will have some examples where you can find it out. Now, we will try to explore the concept of desymmetrization with some very simple examples. I am trying to give you couple of starting materials one by one, and what I am asking that please try to do the desymmetrization of this given molecule, so that the symmetry is getting disturbed. The symmetrical molecule, this is symmetrical molecule. Now, in principle as I said, you can do a single step transformation, you can do a multiple step transformation. But sometimes if there is a very key transformation is available which people often use, which is very unique transformation, we will try to use those transformations. Now, in principle if you see this molecule what are the functionalities? You are having a double bond here, you are having a ketones, you are having epoxides, those are the things are there. Now, in principle basically you can do any kind of reaction, which basically you can do a epoxide hydrolysis with some nucleophile, not water nucleophile, you can just a unsymmetrical nucleophile like sodium azide, that gives you OH and N3, the molecule is desymmetrized. So, like this you can basically put a nucleophile here, but now the point is if you do a nucleophile can attack here, nucleophile can attack here, it can attack epoxide. So, regioselectivity is a big issue. So, the particular reaction which I am now trying to draw here, we will take this compound and subject it to one equivalent of base. Now, base I am using a sterically bulky base like lithium diisoproylamide. Now, we see the structure of this compound. LDA is non-nucleophilic base. It basically having two of these hydrogens which are extremely acidic. Now, these are symmetrical in nature. Okay. So, in principle, initially if you think that you have a base, this base will abstract this hydrogen and they will basically will give you this carbonium carbon ion. Now, is like a Favorsky kind of reaction may takes place because you have a electrophilic quencher in form of epoxide. So, this reacts here to basically give you a give you a basically give you these things. Now, eventually if you now treat with sodium ethoxide or sodium hydroxide, this OH minus now attack this cyclopropane ring because it is strained, and a Favorsky type of ring opening will takes place, which probably I am sure all of you know it. And then you will see that this compound will now converted to a compound like this. Now, this starting material and this product are completely different in structure. Now, this is the desymmetrized structure. Now you may ask that, sir, what is the basic things you are trying to say? I am basically trying to say that this is a very simple transformation. The transformation is a well known transformation. Only thing is this symmetrical starting material is desymmetrized, that is the only thing. Now, if I give this molecule as a target molecule, this molecule as a starting material, probably if you do not mention the desymmetrization term is fine, because it is not required in the sense, but structural features give a sense that the starting material is this and your product is having these things, where the only difference is the symmetry of the starting material has been lost or destabilized. Now, next we will try to figure it out a series of or a set of example, where you see that how this particular compound can be desymmetrized with the help of many reactions. I say in principle you can think about many reaction. Now, probably I will try to put you very simple reactions. Now, this compound is basically a symmetric compound. This compound is a symmetric compound, right. So, what exactly can you thought about? In principle, you can thought about any transformation which will basically desymmetrize the molecule. Simple transformation like Baeyer-Villiger oxidation. Okay. Now, if we do the Baeyer-Villiger oxidation on this molecule, you will find that the left hand side will not be touched, and the right hand side is basically now having a lactone. So, the symmetry is now desymmetrized. Because nothing new, is always known actually. Now, I am saying you treat with LDA, this molecule. LDA will abstract this proton, acidic proton, to basically give you a OLI. Now also this thing is desymmetrized, but OLI normally is not a stable form. You can treat this compound with TMS chloride, the enol silyl ether, you basically get the corresponding OTMS. So, in this way the desymmetrization was done. Now, let us see whether you can do any other desymmetrization reaction. You think about doing a manic type of reaction with one equivalent of reagent. So, then you see you basically get this compound, which is also a desymmetrized reaction. The initial starting material you can simply reduce, do the reduction followed by simple elimination, you can create the alpha beta this unsaturation at this point or this point. So, this is the ways basically you can take a symmetrical starting material and you can just disturb its symmetry through a proper synthetic transformation. Now, I will be giving you example. I am saying that I am giving you this compound. I am saying that this compound is a symmetrical starting material, there is absolutely no issue, because if you consider this 2D structure, this is having a perfectly sigma V. I am saying that this molecule is reacted with LDA. Now, LDA in principle is a very strong base, but it is a nucleophilic base. Now, if this compound was treated with LDA, it has been found that this oxygen Li which is coming from this LDA, it also picks up this inert carbon as it is in close proximity. So, then it basically gives you a OLi and a negative charge here. Now, this negative charge now have a electrophilic epoxide handle at one end, it basically opens up the epoxide. This is also very useful transformation for epoxy alcohol. Now, you quench these things with H3O plus. So, you basically get a allylic alcohol. Now, the starting material is symmetrical, the final product is desymmetrized. So, now if I give you this particular problem that I say that this starting material was given to you, or I can say that how you can make this starting material. The retro for this starting material probably then I am saying a typical diethyl malonate can react with this compound followed by decarboxylation and these things. So, a real problem based on this desymmetrization could be something like this. I say you start with this bromide, how you can make this particular compound. Starting material and your target. So, now if this problem was given to you, you basically have to follow the pathway which I am just now discussed. Take this dibromide, react with diethyl malonate. Now, diethyl malonate is having active methylene group, you treat with excess base, let us say sodium methoxide. Now, 2 hydrogens in principle can be abstracted by excess sodium ethoxide, and then this is a minus and this minus by abstraction of this hydrogen will basically give you reactive this way. So, what you will be getting? You get this CO2 ET, CO2 ET. Now, do the base hydrolysis followed by heat. So, decarboxylation will takes place with one carboxylic acid will be remaining. Now, this one you basically convert to corresponding alcohol by lithium aluminum hydride, that will basically give you CH2OH. Now, this CH2OH you now convert to corresponding MCPBA to basically give you the epoxy alcohol. Now, you treat your desymmetrization reagent or the LDA. Now, this epoxide is initially symmetrical, which we said your desymmetrization reaction. So, now here if you do this desymmetrization as done earlier, you basically come to this compound, which is your product or target given to you. So, reactions are in principle very simple, only thing is you need to have a desymmetrization concept properly exploited. The same line we will try to give you another assignment, probably all of you are now. I say you are having a starting material of this structure and I am looking for this product. So, this one basically you can easily do the retro, probably the chemistry was already explained to you. I am saying that I will be doing a selenoxide scene elimination, what is basically nothing a 2,3 sigmatropic rearrangement. So, this is O minus picks up this hydrogen, hydrogen gives here pH ACOH in all together is leaving. So, now how this you can make this compound? So, initial molecule is symmetrical, this molecule is symmetrical. If you consider only this part, now this molecule is not symmetrical. So, in this way basically we are trying to do it. So, left half and right half is not symmetrical. So, fine, now I say that okay, this compounds you can basically easily make from this ACPH, this also you can easily make from the starting material like this. So, your forward synthesis now starts with LDA and pH ACCl, the electrophilic reagent. So, initial is your anion generation, which will attack to ACCl to basically give you double bond ketone and ACPH. Now, as I said, you need to convert this ACPH to selenoxide, you treat with sodium periodate. So, which basically will oxidize the AC plus O minus. Now, this selenoxide it is basically acting as a base to abstract this hydrogen. In reality, it is basically a 2,3 sigmatropic rearrangement 1 2 and 1 2 1 2 3. So, this goes like this and it goes like this, it comes. So, basically you will get the desymmetrized product with the pH ACOH, phenyl selenic acid. So, in this way basically you can do a very nice desymmetrization concept And similar kind of thing, if I give you another example, I say how you can desymmetrize this particular compound. Now, I am saying that you are having a compound something like this, which looks to be a perfectly symmetrical compound if I do not talk about the stereochemistry, fine. So, is a starting material which is symmetrical, Now, what I am saying that reactions, you need to think about some reactions which will destabilize or which will remove the symmetry. So, I said first we will be reducing this anhydride, because anhydrides are not good functional group to deal with. So, I said first we reduce these things to corresponding OH. Okay. Now, you see OH are nucleophilic in nature and you have a electrophilic double bond. So, any principally unique reactions you can think about. So, let us say you will be doing a simple iodinium ion chemistry, treat with a iodine, you convert this corresponding iodinium ion and then make this CH2OH and this CH2OH. Now, one of the CH2OH will undergo this iodoetherification reaction and then you will find that your final compound will be basically having this kind of structure. So, this is now this molecule becomes disymmetric. So, in this way the symmetrical structures can be very nicely desymmetrized if you try to follow certain very key transformations which you already discussed. Probably we will stop with a very simple example. Let us talk about this acyclic example. I say you are having this example, how you can desymmetrize it. Alkyne you all know, if you react with Hg2 plus in acidic medium, hydration of alkyne takes place to basically give you the Markovnikov fashion. So, you will have symmetrical alkyne. So, you are having this OH, CH2 SeO, hydrogen attacks here, having a CH2 OAC. Now, this basically vinyl alcohol undergo tautomerization to basically give you SeO double bond O CH2 OAC. Now, see this starting material was symmetrical, very much symmetrical alkyne. You do a simple mercury mediated hydrolysis, you basically get a ketone which is now desymmetrized. So, this is the main reaction which I am trying to focus, and eventually this kind of reactions plays a very unique role in eventually. Now, this particular sequence of reaction where from I took it, it also gives you another thing. If you treat this compound with a strong base, a acetic acid 1,2 elimination takes place. You are having this acetic acid. This compound does not have a 1,2 elimination place. So, basically you will be now having base alpha beta unsaturated compound. So, this way the any principal unique reaction or any standard FGI is able to do the desymmetrization reaction on a given symmetrical molecule. So, you just need to focus it on the structure of the molecule, and probably the next lecture will give you a demonstration of such strategy for the disconnection of a natural product, and we will see how this natural products can effectively be constructed with the help of a desymmetrization strategy by applying standard FGI. So, we will talk those things in the next lecture. So, till then goodbye, have a good time.